You are watching a master at work.
It was the whole DeathRacer thing.
These are called DeathRacers. Sam Prentice, the real Sam Prentice. I'll link him here in a minute. I'm building one of these. We are building this on stream.
Phil from 3DP UK here, and I'm building the DeathRacer.
The DeathRacer's lulzbot. The lulzbot DeathRacer was phenomenal. The colors, they knocked it out. They put a octopus on it and everything. It was super cool to see.
Hey, Sam Prentice is here. I just watched the Edutech's Murph video and got to see the DeathRacers.
We have Sam Prentice coming, the Sam Prentice. He's going to be hanging out with Tripod and all the community this weekend, and I cannot wait to say hi to him as well.
Phenomenal.
What is going on, guys? The phenomenal DeathRacers are now a thing. The social media hype train is well underway, so if you've been part of that, thank you so much. High five to you. It's been amazing. The journey, in fact, has been awesome as well. Out to Merth, back to the UK, lots and lots of fallout, lots of feedback from people, and we've got some changes that we're going to be making to these files, so make sure you tune in for that. First and foremost, I wanted to go through things like infill and parameters, because one of the big issues that we had at Merth was people's understanding on how mechanical properties work. So I want to go quickly through that, which we'll do now, and then we're going to talk about the upgraded parts, we're going to talk about alternative motors, and what other people are trying to do, 50% racers, all that kind of crazy stuff. So make sure you keep it locked in, and let's get straight on into this. So welcome along to Prusa Slicer. Those with an eagle eye, you might notice that these are slightly different files to the ones perhaps you've become accustomed to. These are the Pro versions, and they're going to sit a new, slightly different size motor in them eventually. But the parameters are certainly going to be the same on these, and also the V1s. Now then, first and foremost, I am going to set the parameter walls to 10. I am using PETG by Polymaker, and it's the Poly Light version that I'm using at the moment. I'm going to set this to 40% on the infill and also to triangles, and I am going to switch the part cooling fan off. Now there is a good reason for that, and if you look or subscribe to the 3D Print General, he did a whole thing on strength of 3D printed parts, and actually by switching the fan off, it affects the tolerances. And certainly if you're going to be making something like this, which is essentially a rock'em sock'em robot, if you're from America, you're going to probably need something that's going to be as durable as you possibly can do. Now, if I drop down this slider here, you'll see that you do get a huge amount of infill on those parameter walls, especially where you're going to need those particular parts to be strong. So that is going to be my top tip for these particular settings. I'm going to be using that on all the mechanical side of things. So anything that is motor related or drive related, 10% on the parameters, 40% on the infill, and certainly PETG. In my case, Polymaker, there's a link below if you want to look at this particular filament. And of course the same will pretty much go for Cura, although it's called something slightly different. Warline count, I believe it is. Yes, it is. And again, we're going to be setting that to 10. I'm also going to beef up the bottom and top layers to around about 5 or 6. So this is going to be one of those parts that is going to see a certain amount of stress, not just from the motors and the torque settings, but also from any kind of impact. So this was actually one of the parts that Jog Telling Racer actually failed upon, and we had to 3D gloop that up in order to get him into 10 seconds of the race. I will say though that even in standstill, he managed to decapitate my head and win a point there. So Polymaker have produced a range of different impact tests. This is the Charpney impact test, which basically looks at the strain rate tests that determine the amount of energy absorbed by a material during fracture. Now, interestingly enough, the Polylight PLA Pro actually has a better quality of impact than the Polylight PETG 17.1 versus 5.1. And this looks at the Polymide PA6CF, which is 32.8 versus that 17.1. So depending on the material you want to choose, perhaps this chart will come in handy for that unit of measurement. While this chart also focuses on bending strength. Either way, I'll link it below. If it's of interest to you, click the link. Now obviously I appreciate that it's not a Formula 1 car, but if you're going to be racing these things and you're going to be taking them out to an event, you want them to last more than 10 seconds. Isn't that right, Joel? So I've had a few questions on how the rider goes together and how it actually works. Now the idea of this is the boom on the back should be able to decapitate the head, and inside of this there is a little kill switch, as you can see here. Now this is actually a broken DeathRacer now, because the luggage department, when I was on my flight back, have mishandled this. So we've got a few kind of wobbly bits on here, so we're going to be reprinting those parts and adding some slightly different motors in here. So the idea of this particular part anyway is to allow you to interchange your heads, have different racers, customize them as you wish to. So the next thing I wanted to talk about is I'm going to take the racer off of this and show you how this is all put together. Let's get straight on into this one. Okay, so here it is. Maybe I'll put some a little bit of music on in the background for this particular part. So what I'm going to do here is just disconnect the hands from the servo controllers, and as you may have seen in my previous video, these servo controllers basically move back and forth and give the appearance that the racer is actually moving the sticks backwards and forwards to accelerate and turn left and right. So all we do for that is just pop a couple of little M3 screws into these parts here and then straight into his hands. So I'm just going to take those off. Go. Okay. So he is held on by a lot of luck actually, and in fact inside of here I've got some cables that go and attach to this switch. Now this switch goes to the main battery, which should be sort of hanging out the back here. Now the idea is that when you hit that switch it just disconnects the positive cable, and when you turn it back on again then it activates the robot. It takes literally seconds for it to wake back up again. So I think actually in this one I might have glued his foot on, but we're going to take it off anyway. Here we go. Yeah, I did. Look at that. That's good. Okay, so we've lost a hand unfortunately. Pop that back on. So this is what we have. This crotch part here has actually been remodeled in the latest CAD files, so make sure you've got the updated version of that. And all we've got here is two cables that come out. This is just a positive cable that goes to that switch in order to activate the head. He does have quite a curious little sitting position here, almost like he's sat on a toilet or something. It's a bit bizarre, but what I'll do here is I'll deconstruct it at this point so you can kind of see exactly how this goes together. And if you're clever enough and you want to, you can always just rewind this and understand exactly how this goes together. So I'm just going to take his arms off first and foremost. So the way that the switch is actually mounted, there's a little plate just inside here. Again, it's all 3D printed, but it's relatively quick and easy to put this together if you know how. In fact, it can be a little bit daunting. So there's the arms, easily put back together again. And again, all you need to do, just clip those parts in and his hand is there, done. His legs are essentially the same, left and right here. And what I'll do shortly is I'll show you how I look to modify the head in Tinkercad and give you a slightly better idea on how to do that yourself if you so wish to. So where this is broken, I don't know if you can see it here. I'll try and get a slightly better picture on that, but it's literally fractured across here. Incidentally, this framework needs to come out anyway because I'm using the Pro version on this now. So this one will be upgraded, ready for the Droid Builders event in the UK, which is coming up in August, and then it will also then be at Formnext in November, and then probably at some other 3D printing shows. in between that time with any luck. So what we're doing here is taking the kind of body to bits now, and what we're essentially do is show you how that switch goes in. As I was saying before about the infill, the body and the shell of the racer doesn't have to be sort of too crazy. I would say probably with the head I'd put a little bit more infill on that, or some more parameter lines on it, in order for you to at least last without getting completely smashed up. And finally, just take this little screw out here. So what will happen is there is a couple of modified files for this. You can stick a little magnet inside of here. There's a particular part that you'll see for that. I haven't bothered with this because I just didn't feel like it was necessary, and there's a certain degree of gratitude around the driver hanging off of the cart, or hanging on for dear life, depending on how you look at it. So hopefully you can see this. I'm just going to pull this down, and everything's pretty tight in here because it has been knocked about quite a bit. All we're going to do here is just take this side panel off here if we can. Might help if I do this. So hopefully we can now start to move this out. Pushing forward. Oh, I've broken it. Well, no matter. But what you can see here is the framework now and where the switch goes in. I'm going to have to obviously reprint that part because I've just broken it. Again, this is something you're going to find, I think, quite a lot. The fact that these racers are going to get smashed up, and it is very much going to come down to your print settings and your material in order to keep these afloat. So what we've done here, just on this switch, again, I've made sure that these are not exposed. I've seen a lot of people putting these switches together and just using bare wires. Just pop a bit of electrical tape on there just to stop anything from shorting out. I've used a 12 volt graded cable on this as well, out of a computer, and the switch is just a standard I think it's a 5 amp switch. And all I've done is just tighten this down here so that the switch doesn't move. It's tight in there anyway, and then of course once the head is on, hopefully you can see this, it hits the switch into the on position, and as you take that away it then decapitates the head. So relatively simple. Hopefully that makes a bit more sense on how this all goes together. Next up, I'm going to show you how to modify these faces. Here we go. Okay, DeathRacers. So I'm in Tinkercad. Just sign up for a free account, and I'm going to be looking at adding this little minion to my current design, which is just this. So this is what you usually would get. You can then stick a face on the front of it. What I'm going to try and do here is I'm going to merge the two together. What you need to ensure is you're keeping the integrity of this part free and fresh. So whatever we decide to put on the front and we blend that together, we just need to make sure that these parts are good and in fresh working order. Okay, so let's import this one. It's important to know that it will probably try and put it in the middle of the bed. So we'll move this over. Okay, there it is. There it is. Right, so we're going to need to make this a little bit bigger. Let's have a look here. Let's move him out. Move him up. Bonk. He's tiny. Okay, so how are we going to do this? Let's move this around a bit more, make him a bit more of the right kind of size. Maybe like that. That's not too bad. Right, let's move him around. And all I'm going to do is just plonk him just inside here, just to get a kind of feel for the size. Okay. Okay, I don't mind that so much. Then what I'm going to do is I'm just going to whack one of these in. I'm just going to take it to about here, and then that to about here. Okay, and we're going to select that, and we're going to select this. And we're just going to basically hollow out this whole part here. There we go. Now it looks obviously a little bit weird now, but you can redefine this however you like. So what I'll do now, I think, is make this a little bit smaller. Get this to come back a bit into here. This is going to need finessing, I would say, but it'll give you a good idea on, you know, perhaps how you can do this. But the important part is obviously making sure these parts are not being played around with too much. And the other thing you might want to do is possibly take a little bit off of this chin here as well. And the reason for that is you don't want it to catch on any of the switch parts. So I'll probably just take a little bit off of that. Maybe that much. We'll do the same again. Just hollow that out. Yeah, I'm kind of happy with that. That'll do. That'll do for now. And then finally, we're just going to blend these two together. So I just highlight both of those, hit that button, and we make that all into a solid. There it is. Good job. So all I'll do now is just export that into an STL, and here is our little minion. So as you can see here, obviously there's lots of kind of bits and pieces on here that aren't going to be ultimately that smooth. The quality of the print is very much up to you on the sizing that you want to do. This is just something I wanted to do very quickly, just so you guys get a good understanding on how to quickly make something out of essentially nothing. So let's talk about where you can find the files and the new Facebook group. So firstly, heading over to facebook.com/groups/DeathRacer.builders. Here we are, 158 members strong already. It's me and Joel, Jim. All the videos that I've been posting up recently, and lots of tips and tricks from other people from different countries that are looking to install these things. Hey, you know what? This is something that I just went through. So again, people are ahead of the game here, ahead of the curve. And you'll even see things like people's builds, where they're at, what their drivers look like, pancakes, what screws they're using, and also lists of things in the US, the UK, various other countries where people are trying to build and buy these things. Even one here from Greg, who's just got his DeathRacer. The track systems are working, and he seems to have done a fabulous job on that. Probably one of the first, actually, to have got these done. There's Michael's original design. Again, people building these videos, so head on over to the DeathRacers Builders group over on Facebook if you are so inclined to do so. So where can you find the files? I'm going to tell you. So if you head over to Michael Baddeley's Patreon page and log in and sign up, it costs you $1 to be part of this craziness. That's all it is. It's the first tier on Michael Baddeley's page, so you can download the files, only pay $1, and happy days if you so wish to. Or you can go on and you can create other things if you want to, like Star Wars stuff, which I won't get into right now. So once you're into the Patreon, if you click on DeathRacers, you'll see the version 1 DeathRacer file box here. It gives you all the information, including how to put this together, where the YouTube videos are, what you need to be watching, what you need to be buying. Gives you a full list and the BOM and all the information and the CAD files and the Fusion files, everything that you're going to possibly want to make one of these particular robots and modify it to your own design. Brilliant! Now let's have a look at this motor. Now, as you may or may not know, and certainly if you see Joel's video that comes out on Saturday the 15th or the 16th, whichever day that is, you'll see that a number of these did get messed up, including this particular one. In fact, this motor is now seized. And it's also a little bit loose as well. So I'm going to go through a couple of things with this very, very quickly. I'm going to basically take this motor out and see if I can get inside of it and have a look at that. Then I'm going to show you some of the other motors that we're intending on putting into what we're calling the Pro versions. Okay, so I will quickly take this motor out and see what has been going on. And as I say, we put these through their paces. In fact, this motor is probably about 3 months old. It's had more or less daily use. And what we found was, when we were racing these at Murph on the day, we used a tarmac surface, and basically what we found was that the stall current on these are only around about 5 amp. So unless you're putting these on a relatively slippery surface, they're gonna burn out. It's the same as any kind of motor, really. They will, if you put too much stall current through it, they're gonna cause some issues longer term. Now then, let's just whip that out, and as you can see there, that's already a little bit loose, so I'm going to suggest now Loctite in any of these things from now on. What we do now, let's see if we can take that off. I mean, okay, that shouldn't have come off that easily either. Again, these were put through their paces. Let's just quickly take the parts off, and this is something that I really like about this design, is that you can quickly take these things apart, get inside them, and work out what's going wrong. So these are the 110, I believe, Pololo motors, and as you can see here, it's completely seized on this part of the gearbox. So my interest is it the motor or is it the gearbox? That's actually caused the problem here. A number of these did get quite hot, but again, we were racing these on probably an incorrect surface, and I think we know better for next time. So let's just quickly whip this off and have a quick look and see what we can find inside here. Okay, well, the gears look okay. Okay, right, got it. Okay, so here you'll see actually the gears and the gearbox are actually working really nicely, and they're quite fluid. So the failure in this case is actually this motor, and we can see that by the fact that this will just not turn. Now we can go a little deeper on this, but I don't know what it's going to show us past here. I think it's just a framework that they pop on top. I don't think we're going to be able to see anything more inside of this motor. So in order to repair this, obviously the gearbox is okay, but I will need another motor now in order to make this work. Oh, it's slightly moving now. I can just imagine inside of here that this is going to be a real bad mess. But what I might do is I'll probably get to the bottom of that by... Yeah, it's not really turning that nicely. It's very, very chubby. I'll probably... Let's see if I can take this out now. Try and remove this cover and cut into this, because this is effectively dead now. This is not coming back from anywhere, which is a bit of a shame. But the gearbox is good, so all I need to do is replace this motor or find another motor that might be a little bit better. So we have a dead one. All is not lost though. Do you want to go
faster?
So this is coming up next. I don't want you to get too excited and to start ordering these because we haven't tested them yet, but I thought it was going to be worth mentioning, especially as people are now beginning to build these and make these. If you're in the infancy stages, all is certainly not lost, but we have an alternative here, and Michael's been working very, very hard on putting a design together for brushless motors that also come with speed controllers as well. So if you saw tripods build, you probably would have seen something like this. I'm hoping this is going to be pretty damn fast. In fact, we know how fast this is going to be. With this particular gearbox, we should be able to achieve around about 4,000 RPM. So this is going to be 4 times faster than the current DeathRacer. And as you can see here, it is quite a mammoth motor. Oh, in fact, it nearly does fit in there. Interesting. Well, there's going to be some modified files. They should be coming out next week. So today is the 14th. So I'm hoping by next week we should have these 540 motors out and about. So if you're in the middle of building this, or if you want to make a change, or if the Pololo motors are not in stock, if they are in stock and you've ordered them, don't worry about it. Honestly, it is a reasonably big difference, you know, 4 times quicker. But, you know, we want you to succeed with this. I don't want you to fail. So, you know, keep going with what you've got. This is just something that we found might be a slightly better way of working. But again, at this point, it's certainly untested. But that'll be coming out next week, and we'll be guiding you through the process as always on how to make these work.
It was the whole DeathRacer thing.
So unfortunately, all good things have got to come to an end, including this video. So please make sure you hit that subscribe button, head over to the Facebook site, join the Patreon site, and make sure you click the links below to get your Polymaker filament. I'm Sam Prentice, and I will see you next time. Bye for now.
You are watching a master at work.